Yeah, it's all good. And
Okay, let's start with the introduction of our studio. So this is the windows of our studio you can see. So this is known as R console. This is the terminal R script in which you write your codes. And this is the environment where you have built or create the any variables or the data is gonna go right here. And in history, you can see that what we have done so far. So I have earlier used the cars data, house data, or install some packages to the R Studio. So you can get the history from here. So some connections or the tutorial, you can see them, or you can brush them or clear them by using this brush. And moreover, there are some files you can see. So these are the files which are on my laptop, and I can use these files during using my RStudio. Similarly, if I have built some plots, you can see what plots I have been made. So finally, the most important thing, which are packages. You can go for any package you want to download in the RStudio. So you can go for the Abind package and see for the help. So basic introduction has been written over here. So these are some libraries, and you can also install it by clicking install our packages. So if you want to install any package like deep layer, for example, so you just need to write here and you need to select that package. And if you start installing them, it's gonna install. Let me show you. So it will install. I have been installed it earlier, so it's going to install again, but there is no need. Similarly, if you want to recall any library, so library means you have installed some package. For example, you have installed dplayer, so you can recall it by using the library. Okay, so there are some packages like Carrot, Mass, or the Neural Net. Neural Net is a very famous package, and Carrot is very famous package for artificial neural network. So now I'm going to describe you that if you gonna just open your R and your R is totally blank, then you need to go on file. This is new file, and you choose a R script. R script means that there is a blank page for the commands, and you need to choose a work directory for it. So you go on sessions and set work directory as choose directory. Choosing directory means that you are going to choose some folder in which your files or the data has been placed. So this is a directory or the location you are going to give to the RStudio, and it's gonna go work on them. If I have some data in my folder depression, so it's gonna go and it's given a path to it. A path is given to it. You can see in the console that what I have chosen, it has been gonna work on it. Or on alternative, you can write the command or the path and then run it by using this, or you can use the control plus enter to running the commands. Okay, so the command will run. Similarly, if you gonna import some data set directly, you just need to go on the import data set. So on text base, it means that you are going to select .csv file or the Excel file or the SPSS file, SAS files or the stata file. Any file you need to go and you need to upload it. You can easily go there and upload on the data set. So these are the basic things you can go for it. And meanwhile, you can practice. So now coming towards today's topic, we gonna go on the linear regression, and we have done the linear regression. Today we will go for the multiple regression basically. So they are gonna go with, okay, let's start the today's topic. It is the multiple linear regression. So we have done the linear regression earlier. So multiple linear regression is actually dealing with the one independent variable and more than one independent variable and one dependent variable. So you are going to check again assumptions and the data set which we have used for the um, linear regression. So there is also a multiple regression data set. You can download it from here and see that what the data is all about. And there are some packages which you're gonna use are the ggplot2, dplayer, boom, or the ggpub. So we have also installed these packages in the last class. If you do not have done, so you can install them now. So these are the basic steps that you need to import your file as a text base. Text base means the file has been in the format of the .csv. The data frame which we are going to work today is income and happiness, biking and smoking, and heart disease. So which we are gonna work is biking, smoking, and the heart disease. That if somebody is gonna go with the heart disease, it has heart disease. So is he or she biking or smoking or not? So you need to go for the data set and just go for it. Before that, I'm going to describe you with the file that after the simple regression diagnosis, the multiple regression diagnosis is also same, but the basic assumption is that the independence of the observations, that is no autocorrelation. It means that there is no multicollinearity in the data. There is no correlationship between the independent variables of the data sets. If there are some independent variables correlation or the multicollinearity lies in the data set, you cannot use the multiple regression. This is the very basic assumption of the multiple regression. So you choose the commands or for the correlation that hard dot data means that the name of the data, dollar means that you are gonna use a certain variable which is biking. And then the hard dot disease dollar, again the hard dot data is the data name, and dollar means that you're gonna use the variable which termed as smoking. Afterwards, when you calculate these two correlations, you come to know that the two correlations are 0.015, and the other correlation is about the same. The biking and the smoking correlation is very low. It means that if you have calculated a correlation which is above 0.03 or point 3 or point above point 0.3, it's gonna go that they are the independent variables has the correlations, and they are observing the multicollinearity, which is a violation for the assumption of the multiple regression, and we cannot use the multiple regression. Afterwards, the normality check, we are gonna do go with the histogram in these classes. Otherwise, there are some tests like Kolmogorov test or the Simrov test we can use. So by now we just need to make a histogram. So in histogram we write hard dot data as a data name and hard dot disease as a variable name, which is our dependent variable. So when you imply these things, it means that it's a roughly a bell shaped or it follows a normal distribution. It is not positively skewed or not negatively skewed. So we can go for the assumptions of the uh, regression. Now linearity, the third condition is linearity. So you plot the heart dot disease on biking. So you can get with the command plot heart dot disease is a variable name which is dependent variable, and it depends on biking, which is an independent variable, comma data which you are going to use is hard dot data. So you can observe an pattern that it is a linear pattern. In last class we have discussed in detail that the linear pattern implies with the some positive line or some negative line, the downward sloping line or the upward sloping line with the observations, like you can see that they are clearly shown you a pattern. So the linearity assumption is also have done with it. So if you gonna go for it for the smoking, so similarly you can see that this is a scattered plot, but there's the observations are closely lying with each other, the heart dot disease and the smoking data. So you can see that these are the assumptions not gonna go very perfectly, but for linearity in the case of the heart dot disease and smoking, but we go for the linear regression for our analysis, as our other assumptions are meeting the criteria. Now this is the assumption for the common variance. So it's gonna go for the implication. The simple linear regression is which we have done for the income and happiness in the last class. Now you are going to imply biking, smoking, and heart dot disease. So this is the only window we gonna go for it. So let's import the data sets on the R Studio before discussing more. So I'm going to open my zip file, heart.data. In last class, we have observed that the zip file is not working with the R Studio. So now I'm going to copy paste my zip file. So you can also copy paste your zip file. It's very easy. The data I'm going to paste on my desktop to use it, the heart.disease data. Moreover, my data is in heart.csv format. So you can observe it. So now we have done with copying and pasting the data. So opening a new script for this class. You can use the same script also, but I want to make it clear for you. So now I'm going to import my data set from the text base. As it's a .csv file, we will go for the desktop and heart.disease file, attach it. Heart.data, and it's gonna upload. So see that there are the some data frame which you can observe. It is the number of the observation X, biking variable, smoking variable, and heart dot disease variable. So you already look for the assumptions of the multiple linear regression. Now we gonna go for the codes of it. Okay. So this is our data set. Once you upload your data, you can see your data set very clearly just by clicking heart.data. The data will open up, or otherwise you can see the data by using the command of view or str function, which can classify the data variables to you. So you can see very clearly that it has the 498 observations of the data frame. And if you want to expand it, it can expand. If you do not want to expand, then you just need to go back for it. So there are the 498 observations, and for four variables, which are biking, smoking, and heart dot disease, and X are the individual numbers only in terms of integers. Observe that all of the data is in the numeric format, but there are the formats like the ordinal numbers or the string variables or any other variable or the character variable, which we have done in the prior classes. So you can learn it from any of the books or the blogs or some videos. You can go for it. Now going for the multiple linear regression diagnosis, which we have done. So in the regression notes, what we have described, that we are gonna use certain libraries. So I'm just gonna recall these libraries as I have already installed in the last class. Otherwise, you need to install these libraries. These can easily copy paste on the R, and you can run them by the run command or the alter or control. So these gonna go recalling the libraries. So it's going to give you some cautions, but it can work. If they are not gonna work, you can know. So I have done with the recalling my libraries, and now I need to diagnose the first condition with the correlation. The correlation of the two variables. As I have told you that hard dot data is the data name, dollar biking is the variable name, hard dot data, and smoking. Comma shows that these are the two variables which we are going to find the correlation. So 0.015 is a very small value. If this value is a 0.3 or greater than 0.3, then it's a problem for the multicollinearity assumption, which is a violation of the assumptions. So for the other thing which we find that the histogram of the data heart dot disease, you can imply heart dot data the variable. So you can see that the data which is in your environment, you have already all of the variables here. So I can just choose the variable heart dot disease variable. So you have constructed the plot. It is a bell-shaped curve. You can investigate what is a bell-shaped curve. It follows a normal distribution and do not follow the positively skewed or the normal non-normal distributions. So if you gonna extract or export the graphs, you can use these commands, save as PDF or just copying or paste it, or you can zoom the histogram to observe that what is it. So going for the other assumption, which is the plot for it, plot of the two variables, which are heart dot disease. Mhm. The two variables are heart dot disease on biking and heart dot data. So we are investigating separately the heart dot disease for biking. It means this symbol means that heart dot disease is actually depending on biking. So you choose the variable biking, and you just need to be very conscious about writing these spellings. As you are using software, you already know this. And the data which you are going to use is data is equals to which data you wanna use is hard dot data, your data name. So it means that you are going fine with R. If it's offering the libraries, it's offering the variable names, it's all going fine. So I have done some mistakes. So there is some heart dot disease. I have entered the wrong spelling of the disease. So I need to correct it. Heart dot disease. So it will give you the plot, the linearity plot. So it's already, I have just discussed with you that it is linear. Now going for the other variable, which is smoking. How it is? The heart dot disease when depends on smoking. For the data, which is heart dot data. This is the heart dot data, and you imply it here. So multiple times I need to learn the spelling of disease. So you can show you can see this plot that it is not very much fine, but we will go and continue for our analysis. So going for our analysis, it's very easy also. So it is actually when you learn multiple linear regression. After checking out the assumptions and you want to imply, and after downloading and importing all of the data sets, you need to learn this model, heart dot disease model of LM. It's only a name. Then LM means that the linear or the least method of linear squares when heart disease is depending on biking plus smoking. It means that you are choosing the two variables for the diagnosis. So heart dot disease dot LM is just a model name. You can name any name like Numan or like Kenny, any name. And this prompt is actually for the names of the model. So now LM is the method which we imply. So you can also learn from here that LM, some formula, some data, some subsets and weights for the multiple linear regression analysis. It's only a multiple linear regression analysis because the heart dot disease is depending on the two variables, that is more than one variable, which is biking and smoking, and the data is heart dot data. So without delay, we will run it. When you run it, the data has been run, and now you want to recall the summary of that model. So what was your model name? The model name was heart.disease.lm. So you will recall the summary for this model, and you will get the same results like you have already know that the formula is heart.disease is depending on biking and smoking. The data is heart.data. These are the descriptives of the residuals, which means error, the minimum, median, and the maximum. Now, the important diagnosis is for biking and smoking coefficients, the p-values. So p-values are really small. So it means that they are significant. The R square shows the very promising result like 97.9%. You can see the R square. So you can see that residual error is 0.654. So that overall, this is a very good fit model. So let's investigate it on our notes, which we have given, that how it's gonna work for the analysis interpretation. So this output looks like that. I've already shown you the estimate effect of biking on heart disease is minus 0.2. So if you're gonna dig for the estimates of the coefficients of the variables, it is minus 0.2. It means that it has a negative effect on the heart disease. So if you do biking, heart disease is away from you, while the estimated effect of smoking is 0.178. It means that it has some impact or some positive impact on the heart disease. That if you're gonna go smoke, so you encounter heart disease in your future life. And this means that every 1% increase in biking to work, there is a correlated 0.2% decrease in the incidence of the heart disease. And similarly, 1% increase in smoking means 0.178% increase in the rate of the heart disease. Heart rate disease will be increased if you go for smoking by 1%, and it will increase by 0.178%. The standard error of these regression coefficients are very small. As I have been discussed with you, these are the t values, and the very small p-values are almost equal to 0. So you can clearly see that there is these variables which are biking and smoking are significant for it. So moreover, there are some procedures for the model fits like homoscedasticity checking for the regression. So you can go for the last data set for checking it out. Now I'm going for the current data set as we are working on the multiple regression for it. So you going to choose the 2,2 variables and the heart dot disease LM you gonna plot. It means that you gonna plot your model which you have found, and this means that C1, 1, the two rows and the two columns for it. So in the some portions, you gonna imply your graph. So once you imply the charts for your mm, model, so you will get a partial diagram for it. Partial means in parts, the residual versus fitted, the normal QQ plot, and the residual versus leverage and the scale location. So these are nothing but the model fitting values. Like if you gonna use these values for the residual versus fitted. So these are the fitted values means that the predicted values by the model, and these are the residuals means the error. Error means the uh, predicted minus the actual values, the difference between the actual values and the predicted values. So you can observe the graph that how many values are closely related with the zero or the very small values. These are actually very small values. Normal QQ plot means that it's standardized residuals or following the straight lines. So these are the some values. So you just not need to go in very much detail. As a student, you need to learn it, but for analysis, we go and just see that how much your residual standard error is work on. It is 0.654. So if it is very small, it's more good for us. So, but the analysis goes with it if you gonna go imply the multiple linear regression. However, if it's violating the assumptions or you need to go the more closer values or the predicted values, more accurate values, you can go for the other analysis like artificial neural network or other things. So going for the end of this class, visualize the results with class. So these are discussing it. You can learn it from here. So it's actually fitting a regression line. So I'm going to do for the multiple regression, plotting the data and plotting the data like that, the sequence of the minimum of biking data, maximum of biking data, up to the length of the 30 and with the smoking, mean of the smoking data. So how can you imply these things? Here it is written that this is not going to display the results, as I have shown you that this is not going to display the result, but this is creating a new data frame in the environment. So you can see it. And in next step, this is a plot for the predicted values, plotting the predicted values. So it's creating the variables actually for using it in the later commands. So I'm also creating these variables. So now we are going to create a variable as predicted of the dependent variable, and predict.lm means that it is the predict command. It is very much it is an important command. You need to notice it, that how can you predict the model by using the model, by predict the future values by using the model. So this is your model. Heart.disease.lm was your model, and the new data which you gonna plot which you gonna use for the prediction is the plotting dot data which we have described earlier in the environment. So you can see that plotting dot data has 90 observation with 2 variables in the environment. You can see it later on. Now I have introduced a new variable as the plotting dot data dollar predicted dot y. So it's gonna go, it's also going to established in R. So in further steps, there are some commands for rounding up the data, means that the making easy for the data for reading or for using. So it's going to round it on for the 2 decimals. You can see it here. They're just a command for the round command, plotting dot data dollar smoking digits 2. It's rounding up the data on the 2 digits. It doesn't need, it's not very much important to round off your data, but for making the good display, like the visual display, like your plots or something, you can go for it. Otherwise, it's not necessary for the basic analysis. But it's you, if you want to make it attractive, you can use it. So we have used a round of data. In other step, what we do, now you change the smoking variable into a factor variable. So it means that your smoking variable is actually a numeric variable in the start of the class, which we have, I have shown you that it is a numeric variable. NUM means a numeric variable, which you can observe by the command str brackets data. So if you use the as dot factor, you can convert your numeric variable into the factor variable. A factor variable is nothing but a nominal or the qualitative variable. So if you use RStudio to convert it, you can convert it into the character variable. After converting the character variable for smoking data, now plot the original data. They are plotting the original data, hard dot data, and in axis they have taken biking, hard dot disease, and some geometric point, means there are some values that the interval or the just the display thing of the graph. How much you want to make your graph expressible. So you need to work on it. It's not a regular thing that you can learn in just having some single graphs. So this is a hard dot disease plot with the hard dot data and with the variable hard dot disease. When you plot the